and welcome back to the channel. Today we're going to talk about the test rig and the setup that I use to validate the performance of each hydrocyclone design. As most of you may be aware, the Cerami 2.4 is a 53 gallon per minute pump. Now, we don't get 53 gallons per minute out of the gun because that is typically reduced down through whatever type of manifold and agitation setup you're using. In this case, I want to make sure I give a shout out to Jeffrey Pitchford because he came up with this design. He showed it to me, and it's basically taking the output of the Cerami pump and it's redirecting it through a series of banjo fittings, reducing it down to a 1/2 barbed fitting at the bottom on each side to agitate the glass media in the tub. Coming out the top is another 1/2 inch diameter hole. It's actually a 5/8 barb fitting to go on to 5/8 Flexzilla hose that we'll be using for the test. And this basin here is a 44 gallon trash can filled about 3/4 of the way up with water. So I'm assuming it's probably going to have around 35 to 40 gallons of water and roughly 50 pounds of glass media in it once it's all put together. So I'm going to go ahead and take this set up. I'm going to drop it in and get it ready for me to show you how to mount the hydrocyclone. Okay, the pump has been put in the basin. The basin's been filled with about, I'm going to guess, around 40 gallons of water, or a mix of water and a 50-pound bag of Potter's number 13 beads. Now, for reference, this bucket contained the glass beads, and this was its fill level before I placed it inside of the basin. This will be important later, but I wanted to just make note of this is the quantity of glass that's going in there. Now, the most important test you should do before ordering one of the Helix Hydrocyclones is the bucket test. The idea of the bucket test is that it measures the flow rate of your setup. Obviously, the Cerami 2.4 does 50-some gallons a minute, but that's not what comes out the hose. Due to restrictions in the system or the design of your agitation system or the size of your hoses, all of that will be different. This hydrocyclone has been designed to work with a flow rate of about 10 gallons per minute. Now, the way we know that is because we take the 5-gallon pail and we reference the first rib from the top, which is typically where the 5-gallon mark is. And we simply agitate our mixture for a few seconds, get it all suspended, and then time how long it takes to fill this bucket. So I've already timed this. This comes in just under 30 seconds, which is the sweet spot. You could probably be a little under, a little over, and it'll still work fine. However, those configurations haven't been tested. So let's go ahead and get into it. So I'm going to take the slurry pump and I'm going to go ahead and turn it on. Let it agitate for a few seconds. Then I'm going to go ahead and start my test by placing the hose in the bucket and counting how long it takes to fill. All right, there you go. Now, based on previous tests I've performed, this again takes about anywhere between 27 to 32 seconds, depending on the setup or the amount of glass in the system. When this settles down, you will notice that it's about a 30% concentration, between 30 and 40% concentration, which is what most setups use. So this is replicating as close as possible real-world conditions, real-world pumps, real-world flow rates to come up with a benchmark for what the hydrocyclone can do and what flow rates it works best at. All right, so we're going to go ahead and dump this back in, and then we're going to show you how to set up the Helix Hydrocyclone. Before we get into mounting the Helix Hydrocyclone, I thought it would be important to go over the design itself and what makes it work. So this is a two-part design. The funnel, it threads in to the top. Something that you should be aware of is that the threads on the funnel are not intended to make it waterproof or to seal against water. Instead, included with the hydrocyclone is a small thermoplastic ring that goes inside and sits inside a small beveled area inside the hydrocyclone. It's only about, I don't know, 1/16 of an inch thick or 1 millimeter, and making sure this sits in there correctly is very important to getting a good seal. Once you put the top on and screw it down, you'll feel it make contact. Gently give it one additional firm turn and you should be good. The inlet is a 1/2 inch brass barb design. The overflow is a 5/8 inch barb design. And then the underflow or the apex is molded directly in and will fit nicely on 1/2 inch internal diameter tubing, which is included. So let's go ahead and get this thing mounted up. This is my test rig, as I've mentioned before. It's set up this way so you can see how to mount and how it performs. If this was your cabinet, you would just drill the 4 small holes plus a larger diameter hole for the inlet. You can seal it with some gasket sealer or some foam or rubber. However you choose to do it is fine. It does not include mounting hardware because the variety of cabinets that this will go into is probably so extensive. I just want to make sure that what I send works. So just affix it to the cabinet, to the outside of the cabinet. And I recommend putting it up at a height which is convenient for you to access. You'll be probably opening up the door of your cabinet, which in most cases is to the right side, in order to attach the hose. So offsetting it to the right side of the back of the cabinet may be ideal. And once we have this securely attached, one more to go here. That one's a little tight. I'll get to that one in a minute. You're going to go ahead and take your hose, which normally goes to your gun, and take it off. And I just use a little hose clamp, and I put it on the barb. And because I like to do this without having to hold it, I just tighten the hose clamp. This is coming from your pump. Then you should have a piece of 3/4 inch tubing that comes supplied with the kit. And this is intended to be routed back into your cabinet. This is from the overflow for what doesn't get separated. So we're going to go ahead and put that on. And again, this routes back into your cabinet, so you may need to drill another hole if you don't have one already. And then lastly, you're going to want to affix the 1/2 inch inside diameter vinyl hose to the outlet. Now this will go to a bucket. Presumably this is going to be on the floor outside of your cabinet. It makes it a lot easier if that basin is not inside the cabinet. This hose is a little bit of a tight fit, so forgive me if I struggle with this for a second. I just don't want it to come off. It doesn't require a hose clamp because of how good and tight the fit is. There's very little pressure coming out the bottom, so just getting it on even a little bit would be fine. And then take this and place this in your catch bucket, which will be the original bucket that I had with the mark on it. Sometimes it's best to put a little clamp on it to keep it off the bottom so that the material keeps flowing. So that's basically it. We're ready to turn it on and see how it works. So with the Helix Hydrocyclone mounted with the overflow, inlet, and underflow or apex tubes connected and routed, The overflow to the inside of your basin, the output from your pump goes to the inlet, and then the underflow or the apex routed down to your catch basin or bucket. I think we're ready to give it a whirl and see how it does. Now, the process to empty this amount of glass out of this size of basin completely takes about 15 minutes or so. It's something you can just let run. One of the things that is unique about this design is that, unlike other hydrocyclones, when the concentration of the slurry gets below a certain point, it doesn't start spitting water out the bottom. That's really important because I've seen a lot of other hydrocyclones that have been retrofitted to work with our vapor blasting setups. They have a fan of water coming out the bottom, and an additional step of separating water from the catch basin is required. In this design, I've looked to minimize that, so you will see the actual amount of water that is collected after it has finished emptying the glass out, and you can make a decision for yourself as to whether or not you believe this is set up well for this type of media. So without further ado, let's just go ahead and get started. Now initially you'll see the color of the mixture coming out the top as being very milky. This is important to monitor because that'll tell you about how much glass is left in your solution. Coming out the bottom, you're going to see, it's probably a little hard to see right here, is a very fine stream of glass. Very little water. This will continue to operate this way until you are at sub 10% concentrations of glass in your water. There is a point at which the hydrocyclone does tend to vibrate a little bit. That's completely normal. It's about when you get to about half empty with your glass. Just some of the dynamics of the vortex inside change, and it causes a little bit of vibration, but it's nothing to be concerned about. It goes away after a bit. But just go ahead and let this run. You can step away, and we're going to come back in 15 minutes and see how it's doing. Just a quick view of the glass coming out of the apex through the underflow. You can see right here in the bucket that there's very little water. Predominantly what's coming out is glass. I'd say about 90% in our testing has been a good number. 90% glass to 10% water or less. And you can see that it's filling up the bucket. Now, as I mentioned before, it's good to keep this suspended like so, so that it doesn't get its end stuck in the glass and have trouble flowing out and reduce its effectiveness. So I'm going to be adding a little clamp to the top that basically holds this in place so that it can stay in a nice position to continue emptying. So we just crossed the 15-minute mark and we're still emptying. One thing that I did do in full disclosure is I did stir up the bottom of the basin a little bit with a broom handle because there are areas in the bottom of my basin that do not get agitated very well. So I help it along by stirring it up a little bit to make sure that I've got as much of the glass suspended in there as possible. Now, what you're going to notice that we've come down to just a little bit of a trickle here. Now, in other hydrocyclones, you'll see that it's spraying out a lot of water at this point. We're getting very close to the end of separating the glass from the water, yet no appreciable amount of water is coming out the bottom of the hydrocyclone. As a matter of fact, this will slow down to a drip when you get to 90% plus removal. So let's go ahead and take a look at our catch basin. As I mentioned, I put a little clamp on the catch basin, and you can see coming out is nothing but pure glass. Very little water is in the catch basin. I actually lost a little bit of glass because the hose came out as I was running the test. But if you were to take a look on the side to where I made the mark earlier, you're going to see that the current slurry level is about here, and 100% of the media being removed is here. Now, it fills a little unevenly, so it takes a few shakes sometimes to make sure the level is correct. And I'm sure if I let it run another couple minutes, it will get the large majority of the glass out. It's always good to go back in after I have emptied the glass and look at how much is actually sitting on the bottom, because that's a pretty good indication. I've actually emptied an entire basin before and poured out the glass that remained in it, and it was such a small amount. So anyway, this is a quick video showing you where I'm at about the 15-minute mark. I'm going to go ahead and let it run for a total of 20 minutes and see if I can get out even more glass. But as of right now, I have maybe an inch of water on the top, and that's it. I think we're at about the point where we can call this test complete. As I mentioned before, we are literally down to a very small dribble of glass coming out the bottom of the hydrocyclone. There's still glass in this water, but very, very little. I'm sure I could let it run for even longer and get more out, but it's just probably not worth it. Here you can see the total amount of water is still around an inch on top. You can see that my fill line, while there is a little bit of water on there, and I did lose some glass beads to the floor because of that loose hose, I'm almost back, I don't know if you can see that or not, to the level on the side. Getting there. I have to shake it out and make sure it levels off. But by and large, the majority of the glass has been removed without a large amount of water coming out with it. Again, I think this will just keep dribbling probably for a very long time. We're just beyond 20 minutes. And you can see that while there's very, very little coming out the bottom, we still have a good flow out the top. The water is predominantly clear coming out, which means that it's clarified the majority of the glass out of the water. Probably the only glass that's remaining is stuff that's in pockets that was not agitated as well. I think the overall efficiency and effectiveness of your hydrocyclone will be largely determined by how good of an agitation system you have. Like I mentioned, I put a broom handle in and I mixed it up, trying to get as much glass agitated as possible. If you have a better agitation setup than mine, you likely won't have to do that. But the more it can keep that glass suspended in the water, the better. Now, I am going to show you what happens when you shut the pump off. So as you remember, we're down to very small dribble. Now when I turn off the pump, you're going to see a quick rush of water come through. Now that's going to be the water that is actually inside of the funnel when the pressure stops. Now that's going to add a little bit of water to your catch basin, but not a lot. And that only happens when you shut it off. Now that it's been drained, you're going to see that the process is complete. You can now go ahead and either dispose of the media or put in a different grit or whatever you'd like to do.